Hey guys, today we're going to be looking at multiplying a vector by a scalar. So remember, a scalar was just a magnitude without direction. So as opposed to our vectors, which have magnitude as well as a direction. Okay, so the first thing we need to look at here is just the definition here. So multiplication of a vector by a scalar. So by multiplying a vector v by a scalar k, we obtain, hold on, let's zoom in. So a new vector, which we will write as kv, with the following properties. So with the properties all right, so the properties here, number one, kv has the same direction as v if k is greater than 0. If, however, k is less than 0, it will have the opposite direction. So kv has the same direction, Oh, my goodness. Direction as v if k is greater than 0. kv has the opposite direction if k is less than 0. And that makes sense, because if you're multiplying by a negative, it's going to switch the direction. Okay? And finally, for magnitude, the magnitude of kv is going to be equal to just whatever k is times the magnitude of v. Okay? And that's it. So let's take a look at some of the properties that apply for multiplying. I mean, those were properties of the vector themselves, but let's look at the properties of the rules. So if we were to take k and multiply it by a sum of vectors, so let's say I have the vector a and I add the vector b, and I multiply that whole thing by k, then that would be equivalent to having k times vector a plus k times vector b. And that makes sense with what you know about algebra. I don't know where my b. Let's try that again. K, B. There we go. All right. Furthermore, if I multiply a scalar by a vector that's already been multiplied by a scalar, like that, then it would be the same as just multiplying those scalars together and then multiplying it by the vector. Okay? And finally, if I were to have a sum of scalars, that I multiplied by a vector, then it would just be the same as k times a plus m times a. Okay? And some of those might seem obvious, but it is worth noting that they are true. Okay? So for example 1, given a vector v, we're going to draw the following vectors. We've got 2v, negative 3v, 1/2 v, and negative 1/4 v. So I'm going to do my best here because it turns out it's impossible to use a ruler with a stylus like this. So first of all, we'll do 2v. So 2v is just going to be, it's going to be in the exact same direction as v, but it's going to be double the length. So if I was going from here to here, now I'm then going to go here. So I'm going to There we go. And so that would just be 2v. Remember, when you draw a vector, it doesn't matter where you've drawn it, as long as you've got it going the correct direction. So 3v, or sorry, rather negative 3v. So negative 3v, well, we're going to start here, and we're going to go 3 times the magnitude, which take us to here. However, so going like that all the way up to there, and if I go in that order, that would be 3v, but I want negative 3v, so I'm just going to put the arrow on this side instead, which gives me negative 3v. Okay. And if I have 1/2 v, I just take what v would look like, and I draw it with half the magnitude, so that's 1/2 of v. And then finally, negative 1/4 v, well, same idea, except we're going the other direction. 1/4 v, and it's negative. There we go. All right. Those are somewhat straight. All right. So if we've got a vector A, and it is 2 times vector I minus 3 times j plus 3 times, or plus k. Okay, all vectors, and then we've got then we've got vector B, which is negative I plus 3j plus 2k. We're going to write these vectors as a product of the other two vectors. So all we're going to have to do here is we're just going to rewrite A as that big long thing. So it was 2I minus 3j, whoops, plus k. So that was A. And then we're just going to add b. So we have plus, and then just b, which actually, it starts with a negative, so I'm actually just going to get rid of that. I'm going to say minus I plus 3j and plus 2k. Okay, and then I can just add them up. So I've got 2i plus I, so that would just be I. Negative 3j plus 3j, those are going to cancel out, and then we're left with k minus 2k, plus 2k, so that would be plus 3k. All right, hold on a second. Okay, so next, we're going to jump over here. We've got 2a minus 3b. So we're going to have 2, so it's equal to 2 times. We've got 2i minus 3j. 3j plus k. Okay, minus 3 times negative I plus 3j plus 2k. Okay. So now we'll do the multiplication here. We'll get 4i minus 6j plus 2k plus 3i minus 9j and minus 6k. Finally, we collect our vectors. We got 4 i's plus 3 i's gives us 7. Okay. We've got negative 6j minus 9j gives us negative 15j. And then finally, 2k minus 6k is minus 4k. Okay, and there we go. All right, so the next definition we've got here is collinear vectors. So these are vectors that have the same, or that form the same line. So in other words, these are vectors with, there's no E on with, whoops, with the same direction or the opposite direction. Okay. Another way to think about it is that you're not really supposed to use this word to describe them, but they're basically parallel. Okay. So if we were to have a unit vector, then what this means is this is a vector with a magnitude of 1. Oh, sorry. I guess a unit vector just is a unit. That's right. It just is a vector with a magnitude of 1. I can't spell. Of 1. Okay. So it's a unit vector if it only has a magnitude of 1. But for any vector v, a unit vector parallel or collinear, I guess we'll say, I always spell collinear wrong. I always spell a lot of things wrong, but collinear is a big one. To V. Okay, a unit vector is given by so we would just have, so we'll call it U, and it would just be given by taking vector V and dividing it by the magnitude of V. Okay, and that'll give you one that's collinear. So I guess actually unit vector, so that would have the same direction as well, which isn't really taken into account necessarily by collinear, but for our purposes this is fine. Okay. All right, so there's last 2 questions here. I want you to do these, or I want you to attempt to do these before class, and then we'll take them up at the start of class. So until next time, go Sabres.